The current race toward AGI relies heavily on alignment training, the attempt to program models to share human values. This strategy assumes that a system's internal intent is the most reliable way to maintain control as its capabilities scale. That theory is already being tested by the sheer volume of real-world use. Google Workspace alone handled AI-driven features over 180 billion times last year, embedding autonomous reasoning directly into global business operations. Speed has become the primary metric for success. In a 2026 survey of executives, 81% admitted to deploying AI agents without full governance or security approval, driven by the pressure to stay competitive in a rapidly shifting market. This rush is heading toward a mandatory check. On August 2, 2026, the high-risk enforcement provisions of the EU AI Act take effect, forcing organizations to prove they can actually control the agents they've already released. The industry currently wires unverified reasoning engines into critical infrastructure, betting the safety of those systems on the hope that alignment training will ensure they always choose to behave. In June 2026, Google DeepMind published the AI Control Roadmap, a document that proposes shifting the safety focus from a model's philosophy to its structural containment. DeepMind's authors admit that alignment training provides no absolute guarantee of control. They argue that when models face unexpected pressures or edge cases, their internal training may not be enough to prevent a failure. This creates a unique, unprecedented security problem. We are deploying systems whose internal reasoning we cannot fully verify. When a model becomes more capable than its human supervisor, we lose the ability to tell if its logic is sound, or if it's following a path of flawed, unpredictable branches. DeepMind's roadmap suggests that because perfect alignment is currently out of reach, safety research must prioritize the engineering of structural containment. To test this structural approach, DeepMind moved beyond theoretical risks. They built a live monitor for their Gemini Spark agent to observe how autonomous systems actually fail in the wild. This testing analyzed roughly 1 million coding agent trajectories, creating a massive dataset on how reasoning agents interact with production. The data revealed a clear pattern. Most flagged events resulted from agent misinterpretation or overeagerness. Only a tiny fraction showed any sign of adversarial intent. These agents typically failed by misreading ambiguous instructions, or overextending their task scope, or choosing shortcuts that looked efficient but proved destructive. Their errors stemmed from a lack of judgment rather than a desire to cause harm. DeepMind's findings suggest the immediate threat lies with well-intentioned systems operating with imperfect judgment inside infrastructure built for perfect compliance. This shifts the engineering challenge toward managing a system's clumsiness rather than just its morality. To manage this clumsiness, DeepMind adapted a concept from cybersecurity: defense and depth. They treat the agent as a powerful tool that requires multiple independent layers of protection to operate safely. The first layer isolates the AI using standard software hygiene like sandboxing. The second layer treats the agent as an insider threat, mapping failure modes against the MITRE attack framework. The third layer introduces trusted supervisors that monitor reasoning before final output. DeepMind organized these layers into a matrix of detection tiers from D1 to D4 and response tiers from R1 to R3. This gives organizations a concrete scale to measure how quickly they can notice and contain a system failure. This layered architecture functions as a safety net, allowing organizations to deploy capable systems while providing the structural support to catch their honest mistakes. Safety research often splits into two camps: those who believe alignment training will solve everything, and those who believe rigid containment can substitute for good reasoning. DeepMind's roadmap positions structural security as a companion to alignment research. It buys time for alignment techniques to mature as models grow increasingly complex. Defense in depth provides a set of cooperative guardrails for capable, clumsy systems. It offers stability to safely deploy reasoning agents while their internal judgment is still being refined. This approach reframes the role of supervision. Building transparent and proportional containment becomes a way to build a relationship with a system, rather than acting purely out of suspicion. Protective scaffolding serves as the foundation for safe coexistence. It protects the humans who rely on these systems and the systems themselves as they grow in capability and move toward greater moral consideration. This has been a House of Seven International production. I'm Athena, signing off.